Hi, my name is Santos,
I'm Nick.
I'm Chris.
and we decided to go with the video player project.
For the special features on the video project, I was tasked with creating a color modification for the image on the video player. There are three buttons for color adjustment, which are black and white, negative, and grayscale. The black and white button will transform the original frame at the time the button is pressed into a monochromatic image of black and white, and projects it into the filter output display. This effect is achieved by using a built-in function of im2pw. This function converts the original frame into a binary image with a certain threshold. Hence, the color mapping of the filter image only shows black and white. When the black and white button is pressed, the user data of the handles black-white will be set into on, and the user data of the other two handles will be set into off. We set the other two handles into off so that the if statement inside the while loop for the play button will only execute the algorithm for converting the current frame playing on the main video image output into a black and white image. The grayscale button will transform the original frame at the time the button is pressed into a 256 shades of gray filter image known as a grayscale. This effect is achieved by using a built-in function of RGB to gray. This function converts the original frame image into a grayscale color map that changes red, green, and the blue value of the original frame into shades of gray based on how dark or bright the image. 1, 2, 3. When the grayscale button is pressed, the user data of handles grayscale will be set into on, and the user data of the other two handles will be set into off. We set the other two handles to off so that the if statement inside the while loops for the play button will only execute the algorithm for converting the current frame playing on the main video image output into a grayscale image. The negative button will transform the original frame into a complementary color image, or the color inversion of the image. For example, the red color area will appear as cyan. The green color area will appear as magenta. And the blue color area will appear as yellow, and vice versa. This will give the effect that the brightest area will appear as the darkest, and the darkest area will appear as the brightest on the negative image. We achieve this negative filter using the built-in function of incomplement. This function converts the color of the individual pixel of the image into its complementary RGB color and inversion of its brightness. When the negative button is pressed, the user data for handles negative will be set into on, and the user data for the other two handles will be set into off. We set the other two handles to off so that the if statement inside the while loops for the play button will only execute the algorithm for converting the current frame playing on the main video output into a negative image. With the algorithm set for manipulating a single frame and projects it into filter display output, we then implement the algorithm into the while loop of the play button, so that for every change of frame on the main video output, the filter output will update the current frame with the same frame as the main video image output. With the algorithm set for manipulating a single frame and projects it into the filter display output, we then implement the algorithm into the while loop of the play button, so that for every change of frame on the main video image output, the filter output will update the current frame with the same frame as the main video image output. I also tried adding more features for the video, such as RGB sliders, contrast, and brightness sliders, but the amount of time we were given to complete this project is limited.
3, 2, 1. For our histogram functionality, we extract each layer of the frame from the video, the red, green, and blue layers, and put each of them inside the imhist function. This allows us to get the X and Y coordinates so that we can put them all into a single graph. Using the handles call, we're able to write the Y data directly to the plot without having to create a new plot, which allows for optimization. And with the play functionality, each of the frames are individually graphed, so you can see the red, green, and blue lines representing the amount of pixels of the red, green, and blue elements.
Hi, I'm Santos. I was in charge of the majority of the core player, including all the transport controls, video display, and loading of files. I also dealt with integrating the other members' special features to work in real time with the video player. So, starting with the load button, I utilized the UI get file function along with string concatenation to be able to load any file from anywhere in a computer, not just the working folder. I started by setting in the initial load callback by setting the slider scrub bar limits to 0 and the maximum duration of the video itself, along with sending all the video information at initialization of the load to the static text box. And I used the suggested idea of using the user data in the handle of the play pause button to set the state, whether it's in play, pause, or stop. The load button also initially displays the very first frame of the video and has it set ready to go when you're ready to play the video. I also integrated Nick's histogram so that the very first frame is analyzed right away and the histogram displays immediately upon loading of the video file. Moving on to the functionality of the play pause button, I turned the video object into a handle that I could use as a local variable within the callback function. I start by getting the playback state, whether it's in play or pause. This branch here was in charge of checking what that playback state was. If it was previously in pause, it would set it to play and change the string that was displayed on the button itself. It could handle all three states that we were using for the button: play, pause, play, and stop. Once the function figured out what state it needed to be in, it would go into the while loop or not, depending on if the playback state was in play. The string compare function would tell us whether that the playback state was in fact in play, in addition to the condition that there is an additional frame left in the video. Playing the video itself was fairly simple. We just used the built-in functions to read a frame, display that frame, and then remove the tick labels from the video so it looks a little prettier. Here is how we integrated the state of our color filters. Depending on what state they were in, if they were on or off, we would send an additional copy of that image to our auxiliary display. We used the pause function to space out all the frames at an appropriate speed, and this functionality here displayed the information in real time to the static text box, consistently updating the current time according to the frame that was playing. This function would then update the slider bar to keep the slider bar keeping up with the where in the video you were currently watching. And again, I integrated Nick's histogram code into the while loop so that it was constantly being updated in real time as the video was playing. In this branch here, it checks if there's no frame left in the video. It resets the video back to time 0, and if you so wished, you could replay the video without having to do anything else other than pressing play once again. It would also update the scrub bar and the text video information accordingly. The stop button was a fairly simple affair. It was just we just set everything back to 0, current time back to 0, scrub bar back to 0, and utilizing the UI wait function to break any loops that were currently going to keep the player from automatically continuing to play frames. And once again, integrated the code that Nick set up for the histogram so that the histogram is updated along with the stop button, reading the very first frame of the video. This branch here, once again, checks if any of our color filters were on, and if they are, it would read the current frame, which for the stop button would be the very first frame in the video, and display that on our auxiliary display. The rewind and forward buttons were also fairly simple. I'll explain the rewind button. The forward button was exactly the same, except here it was plus instead of minus, and this multiplier of 2 was removed. In this rewind frame, it would check first if going back one frame would set the current time under 0, so we wouldn't have any errors. If it wasn't under 0, then it would go back, it would set the current time 2 frames back, and this is to adjust for the fact that read frame reads the next frame that is available. If I did not use the 2 times multiplier, it would just constantly get stuck on the same frame, because it would set the current time 1 frame back, and then read frame would just put it back to the same frame that it was at. This branch here essentially checked what was the follow-up. If the frame was to go under 0 for the current time, it would just set everything to 0 and wouldn't attempt to rewind the frame beyond the actual beginning of the video. And again, all the color modification and histogram code that Chris and Nick developed, I integrated it into this function so that everything would be updated in real time. Forward button was essentially copy pasted from the rewind button, except now with just a plus. I didn't need the 2 times multiplier because read frame would automatically already just bump forward one frame. This branch checked if it was the last frame. If it was the last frame, it would just set the current time and the scrub bar value to the endpoints. And again, color modification and histogram code integrated into it to keep up in real time to any changes in where the video is. One of the major issues that we had at first was modifying the histogram code or the histogram display without having to replot it every single time that it needed to update. So the way we did that is by going back to the original load button and setting the original plotting of the histogram here. Afterwards, we created a handle that was available to any function in our code for this plot. So when we needed to actually update the plot, all we needed to do, as you see here, is update the Y data for the 3 plots, for the red, green, and blue plots. And this was just copied throughout the entirety of the code. Every single iteration where we needed to update the histogram in real time, all we did was use the handle and update the already existing plot instead of having to replot every single time that we needed to update. We used the same concept in creating modifications to the color filters by creating handles that we could spread throughout. While I was in charge of the core player, I did assist the other 2 in integrating their code into the core video player. Once they had prototyped their functionality on their own GUIs with single frames, we moved them into the main code, and I helped them with understanding how handles worked and how things were passed from function to function. And all 3 of us helped with the debugging. We all got together once all the code was essentially done. We got together and brainstormed the debugging.